All right, so margin of error is pretty straightforward. It's based on the idea of the empirical rule. The empirical rule, if you go back and look at that, here's the average and the mean. Okay, within one standard deviation on either side of that, or in other words, a z-score of -1 to a z-score of +1. In other words, you're within one standard deviation. 68% of the data fall in here. Okay, two standard deviations, roughly. Right, that's 95% of the population fall in there. Again, this is about 2 standard deviations. Okay, turns out that about 2 is actually 1.96 standard deviations, and even that, it's about plus or minus 1.96. It's not exact; it's pretty close. It's actually 1.959, yada 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 yada. And that and a dollar bill get you a cup of coffee at McDonald's, knowing that. Okay, but it's about 2 standard deviations. So the game is this: when you go out and collect a sample, you can find a confidence interval for the true mean. Again, only the good Lord knows the actual mean of, let's say, butterfly wings, how long they are. Huh? But I would like to, as a butterfly studier, I don't know what that's called, but as a person who studies butterflies, I'd like to know this. So I go out and sample, let's say, 60 butterflies. Now, the more that I sample, the less varied my sample will be. Okay, because obviously I'm going to get a lot of them that are right around the average. Okay, and I'm going to get a few weirdos that have really long wings and a few weirdos that have really short wings, but for the most part, they're going to be right around average. And so what happens is this: I am looking for this unknown mean. Okay, I don't know the actual population mean. Now, your book doesn't necessarily use that, but I like to write it out this way. This is because that's how you'll do it in stats 243 and 244. You're looking for this guy. I don't know what they are, Jay. Neither do I. So let's go find out. So we go take a sample average. Okay. And we will also then compute the standard deviation of the sample. Oops, what just happened? Oh, no. So S sub x is the standard deviation of the sample. Okay. We're going to divide that by the square root of the sample size. N is the sample size. So in this case, it might have been 60 butterflies. Oh, that's cool. And then we're going to multiply it by, in this case, 1.96 because I want to be 95% confident. Now watch what happens. This is the standard deviation. This whole thing is the standard deviation of the sample. Standard deviation. There it is. Okay, that whole thing. And so what do you want to be? You want to be within 1.96 standard deviations above, and that to be on this side, or below the mean. So another way to write that is to say it's x bar plus or minus 1.96 over square root of n. Okay, now this is for a 95% confidence interval. Okay, in other words, you're 95% confident that the true mean lies between there. Okay, so what are you going to do? Well, let's go out and sample 60 butterflies. I'm going to write that down again, 60 butterflies. Obviously, I have to specify them because some are tiny, some are big. So monarchs, let's say. So we all are on the same page what kind of butterflies we're catching. Okay, and from that, we find the average of the sample. They had 3.7 centimeter wings. I don't know. I just measured that. Is that height, Jay, or width? I don't really care. It's a problem, friend. Okay. Now, what was the standard deviation? Well, the standard deviation, okay, was, let's say, 0.7 centimeters. Oh, cool. So let's do the math. It's going to be x bar, which is 60 plus or minus 1.96. Again, this is about 2 standard deviations. Times 0.7 over the square root of 60. This whole thing here is what is referred to as the margin of error. Okay. If I was a person who brought politics into class, which I am not, then it would be kind of interesting to talk about sometimes polls then you get into this whole mess of, who believes which poll, and then, oh my word, I don't do that anymore. I'm not going to talk about it. Even though I know what I'm talking about, it just, people get all weirded out by it. So it's interesting to talk about sometimes, but then it leads into this ginormous mess. So I don't. But this time of year, you will hear frequently that so-and-so has a, favorability rating of whatever with a margin of error plus or minus 2 percentage points, okay? Or 3 percentage points or whatever it happens to be. This is the idea. That's what the margin of error is. I hit enter, and I see it's 0.177. I'm just going to call that 0.18 if you don't mind. So what does this tell me? It tells me that the monarch butterfly has an average wingspan that is somewhere between 60.18 on the top end, and then 60 minus 0.18 is going to be 59.82. Did I say 60? Oh, I'm sorry. They don't have 3.7, stupid. Let's try that again. 60 centimeters is a big wingspan. 60 was the number of butterflies we looked at. I apologize. So 3.88 centimeters on the top end. That's the biggest one I expect to see. On the lower end, 3.52 centimeters. Okay. And I am 95% confident, we say, that the true mean for monarch butterfly wings is between 3.52 and 3.88 centimeters. Could I be wrong? I could be wrong. What's the chances that I'm wrong? Well, listen, if I'm 95% confident, there's a 5% chance I'm wrong. Okay? So, again, we want to be confident. We want to be able to say something, but we don't want the target to be too big either. This is a fairly small target. That's from top to bottom. Up top to bottom, that's 0.36 centimeters. You with me? That's a pretty tight window of confidence. I'm pretty confident in that. Okay? If you were telling me that the presidential approval rating was a margin of error plus or minus 20%, but you're 95% confident in that, I'm telling you, friends, if it's plus or minus 20%, and let's say people were favorable of him, they said 40% of the time, that could be as high as 60, it could be as low as 20%. That is a huge swing. No one would be okay with that. That would be like saying that you're 95% confident that you could shoot this barn. Where? From what? The barn's huge. Yeah. From where though? Like a mile away? Is that what you're talking about? No, I meant from right in front of it. I'm like, well, that's not saying much, pal. I hope you can hit it when you're standing right in front of it too. Now, if you could hit a pie plate from 100 yards, that's a pretty good shot. If you could hit 95% of the time, that's saying something. If you take that same pie plate out to, let's say, 300 or 400 yards out there, and you're like, yeah, I could hit that thing about, 3% of the time, then you're not very confident. So the idea is you want a big enough target that you can be confident that you can hit it, but you still don't want it to be so large that it's not saying anything. Like I'm 100% confident that anybody can shoot a BB gun, let's say, something like that, and hit a barn when you're standing right next to it. Gosh, I hope so. And yet, if your target were smaller, again, like say a pie plate, and let's say it's back out there, out at a distance, I don't know, let's say 100 yards. We're gonna have to obviously not use a pellet gun at this point. But if you could hit it 95% of the time, hey, you're a pretty good shot. Atta kid, nice work. All right. But if the target had to be the size of a school bus to hit it at 100 yards, you're not too good a shot. Okay. Or if you said to me, well, yeah, I can hit that pie plate. Well, how often can you hit it? I can hit it 3 out of every 100 shots. Dude, that's terrible. So the idea when we say we want to be 95% confident, that's the idea that we want to be able to state something and be like really confident in what it is we're saying, and let everybody else be really confident in what we're saying. And yet we want the target to be small. In this case, it's no more than that. We're no more from bottom to top 0.36. Okay, and that's how they work. And in statistics class, you'll get into that a lot, because if you just take an average, you got this average. Okay, that's cool. What does that tell me? Well, I don't know. I took the standard deviation. What does that tell me? Well, I don't know. When I put them together and create a confidence interval, okay, the thing I don't know is this guy, and I'll never know it. I can't possibly find them all. It's not possible. the time, the effort, just the fact that there's gazillions of them, I couldn't do it. I couldn't possibly catch them all. And so all I need to know is have a pretty good idea of what it is. Okay? And most things in life, I will never know what mu is. All right? If I want to find the actual overall weight of all rabbits owned by my friend, I could go weigh them all of that he has currently. Yes, I could. I probably wouldn't take a sample of them because there's 12 or something. Okay? But if I want to take the weight of all rabbits in the U.S., I couldn't possibly find them all. I couldn't do it. But guess what? I could take a random sample and have a pretty good idea what they really are. Okay, so that's the point. Okay, and again, this right here will be your formula for 95% confidence interval. There's your average from the sample. This is your standard deviation from the sample. And this is the number of people or rabbits or whatever that you surveyed. Okay?